Hi everyone, this is a quick tutorial on how to export your component design into a GDSII file automatically. For photonic integrated circuit designers, GDSII is a de facto industry standard for the final IC layout and fabrication. In some cases where you already have the GDS file, you can import the structure from the GDS into our component level simulation tools, such as FDTD solutions, mode solutions, and device for simulation and verification. We have several features for you to use. 1. The import GDS function. 2. The layer builder utility. And 3. The GDS import command. For more detailed information, please visit our knowledge base. However, in most cases, we want to do the opposite. We often start off with our component simulation tools first. We create the physical structures from scratch. If the structure is very complex, or if we want to parameterize the structure, we may use the structure group approach. Then we run the simulation, and if necessary, we run some parameter sweeps and/or optimizations in order to find the best design. And finally, we somehow convert the structure into a GDSII file as the final output of the design cycle and send it to the foundry for fabrication. So the question here is, can we automatically export the component design into a GDSII file so that we don't have to redraw the physical structures again in the layout tool? The answer is yes, and I'm going to show you how in the next demo. First, let's open a test FSP file. As you can see on the screen, there are a bunch of random structures in this file. Next, I will open the GDS auto export script file. There are a few associated script files that are also needed, as shown here. The user instructions are provided in the comments, including the workflow, namely what you need to specify, and some important notes on the requirements and limitations when using this package. Please read the notes section carefully before running the scripts. The first thing we need to do here is to load the simulation file. Then step 1, define the output GDS file name and the top cell name. Step 2, define the layer properties table following this format. Each row separated by semicolons will have the layer number, the z-center, and the z-span. Step 3, define optional settings, especially the number of points for the discretization of non-Manhattan objects. Once you have all these parameters defined, simply run this script. The log messages in the script prompt window will tell you which objects have been detected and exported, and the exported GDS file can be found in the current working directory. If we open the GDS in a layout tool like K-Layout, you can see all the cells on multiple layers. Now, let's look at a more realistic design. Here, I have a directional coupler, so I will change the simulation file name and the layer definitions. Rerun the script, and it will give me the right directional coupler in the new GDS file. Okay, that's the quick demo. I hope you will find this feature useful for your design work. Just to clarify, this feature is not intended to replace the circuit layout tools. Rather, the purpose is to help you export the geometry of a component that you already set up in FDTD solutions, mode solutions, or device into a GDS2 file, which can then be added to your circuit layout. You would still need to do the routing in the layout tool. Finally, as always, we welcome your feedback. Please post your comments on kx.limarco.com. Thank you.